So one of the very important concepts that you learn in 7th grade is the distributive property. Here's the definition for the distributive property. Obviously, we're going to go through examples and make it a bit clearer than this, but very specifically, it tells us that the distributive property says that multiplying a number by a group of numbers added together is the same as doing each multiplication separately. So in other words, if I had this, 3 times the quantity of 2 plus 4. And keep that in mind that when you see the parentheses around a group of numbers, you always use the term the quantity of. I'll put that over here so that you don't forget. Parentheses means the quantity of. And you should already know that anything inside parentheses you do first, but that's the proper way of saying it if you're telling somebody the expression that you've written. So here we are. We have 3 times the quantity of 2 plus 4. And I like to think about the distributive property as actually distributing something. When I distribute, it means I give it to everyone. So what I mean by that is the 3, you see here, needs to get passed inside to the 2 and the 4. And we don't want to miss either of them because we don't want to have a sad 2 or a sad 4 because they didn't get a 3 and the other one did. They do get a little jealous. So what we do, and I like to, use sound effects, as you know Mrs. De Silva does. When I send the 3 in to everybody, we have to go, woo! And then, woo! See how fun that is? If you do that every time, you'll always get it right. So that means I sent 3 into the 2, so that means 3 times 2, and 3 into the 4, which is 3 times 4. And that means that the 3 has been distributed across to the 2 and the 4, meaning 3 times 2 and 3 times 4. If you actually do out that math, you'll find that you get the same exact answer because 3 times 2 plus 4, well, that would mean that I do 3 times 6, which is 18. And then this one would give me 3 times 2 is 6, plus 3 times 4 is 12. And when I add those together, I still get 18. As you can see, they are the same. Now, sure, you may be asking yourself, why would I do such a thing? Well, for instance, if you're given a problem such as 3 times, and I'm not even actually going to put it in an addition problem to begin with, suppose you have something difficult like 3 times 54. Who knows their 54 tables? Well, obviously no one. So we think about making this easier, and I know all of you have heard me say this in class when we're trying to figure out math in our head and using logic to get through it instead of hopping right on that calculator. So I know that I can I can break up 54 into 50 plus 4, because that's the exact same thing as 54. And I bring that 3 right down. That means the same thing, but now it's very easy to do in my head. So I get to do the distributive property. Be prepared to woo. Here we go. Woo! Woo! See how fun that is? Okay, so I wooed over here and got 3 times 50 plus 3 times 4. So you should know 3 times 50 is 150. That's easy enough to do in our heads. Plus 3 times 4 is 12. So therefore my answer is 162. So I took what might have appeared to be a problem I needed a calculator for, and I did it without one. And if you use your calculator, I'm sure that you will want to maybe check these out when you first start doing these, but we know that that's correct. So let's try another one. Let's suppose we have 6 times, let's do 78. Now I know based on the first problem that I did, you might be inclined to change that to 70 plus 8. But we're not going to do that because 78 is much closer to 80. So I'm just going to break that down into 80 minus 2. And you should know that 80 minus 2 is the exact same thing as 78. So I'm going to put that in parentheses. I'm going to be multiplying times 6. Do you know what's coming next? Here it comes. Woo! Woo! 6 times 80 minus, and you see how this time we brought down a minus, because it is minus. The first one was addition, the second one is subtraction. And then 6 times 2. So 6 times 80, well I know that 6 times 8 is 48, so this is 480 minus 6 times 2 is 12. So again, you should be able to do this in your head if you think to yourself, 40 minus 10 is 470, excuse me, did I say 40? 480 minus 10 is 470, and then take away 2 more, I get 468 as my answer. And again, go ahead and double check that on your calculator, but we do know this to be correct. So you might have seen some form of this in the past, but either way, please get this in your notes so that you have examples. And really, folks, don't forget to woo, because if you don't woo, you might just get it wrong. Carrying right along. So you've seen this with numbers. Let's just make sure that we have, very definitively shown what it does. So in other words, if I have A, which we know is a variable that represents a number, and on the inside of those parentheses, I have B plus C. So this says A multiplied by the quantity of B plus C. So I know if I go woo and woo, it means that I've given an A to everybody on the inside, so nobody's sad. So that gives me A times B plus A times C. And hopefully you remember that when I have two variables multiplied together, A times B, I just simply write that as AB. When they're right next to each other, they're being multiplied. Plus A times C is AC. Now, in the extreme near future, we are going to be looking at problems that look something like this. Well, I'm going to show you in two different ways. So first of all, let's look at this. This says 2 times the quantity of n plus 8. I've got 2 times the quantity of n plus 8. And let's remember that n plus 8 does not mean 8n. That doesn't make any sense at all. That's like saying I've got a chair plus a table, so I have a table chair, which is not a thing. So we ignore that, like moving right along. Here we go. Woo! Woo! So I know that I have 2 times n plus 2 times 8. So 2 times n, I know when I have a number multiplied by a variable, I simply write that as 2n. Bring down the plus. 2 plus 8 is 16. Or 2 times 8, sorry, is 16. And that, and I know this is going to make a lot of you uncomfortable, but that is your final answer. We cannot mix 2n plus 16 because they are not the same. 2n means 2 times n. Nowhere in there is 16 being multiplied by n. So this is not equal to 18n. Do not write that. This right here is your final answer. Let's look at another one that's same but a little bit different. So suppose I've got, I don't know, let's say 4 times the quantity of 1/2 minus y. Oh my gosh, she put the variables in. Yes, we've been dealing with variables all year, so you should be very comfortable with this. If not, just take it slow. I know you've got this. So here we go. We're going to go woo, and then woo again. Now I know wooing is fun, but I have to warn you, there's no excessive wooing, because you don't want to hurt yourself when you're doing your math, just to be clear. So I sent a 4 into everybody on the inside, so everybody's happy. So that gives me 4 times 1/2. This times it's minus 4 times y. So 4 times 1/2, hopefully you remember the math Macarena. So I need to put my 4 over 1, and then I get to keep the top with the top, which gives me 4, because 4 times 1 is 4, and the bottom times the bottom. 1 times 2 is 2. Last we will reduce 4 over 2. 2 is too little to hold up that big giant 4, or you can just simply think about it as a division problem. 4 divided by 2 gives us 2. Oh, that's a funny looking 2. Let me fix that. 2 minus, and I know that 4y, 4 times y is equal to 4y. Again, that is your final answer. Do not try to do anything else. Final answer. So, let's look at some of the problems that we might be, or something similar to the problems that we'll be seeing as we get into the next lesson in Unit 4. So, we do a lot of things like this. So we would have x, this time they put the x on the outside, x times the quantity of 1 plus 1/4. Now you really have two choices here. You could add 1 and 1/4, or you can distribute and then either leave it like that or put it together afterwards. So let's take our first stance here and add them together. 1 plus 1/4. Well, I know that I need to get them into, so they're both fractions. I know that 1 is a whole, so that's how many fourths? Well, obviously 4/4 plus 1/4. 4/4 plus 1/4 is 5/4. And I know that's being multiplied times x, because the parentheses tell me so. But of course, when a number is being multiplied times a variable, I never write it like that. So my final answer is going to be 5/4 x. Let's look at this very same problem and just do it a little bit differently, using what we know about the distributive property. So here we are, we've got x times the quantity of 1 plus 1/4. Here we go. Hold on. Woo! Woo! Isn't that fun? Oh, I know I say that every time. It's just very exciting. So anyway, everybody on the inside got an x. So x times 1, of course, is 1x. And hopefully you're familiar with the fact that you only really need to write that as x. Plus 1/4 times x. So that, of course, is plus 1/4 x. Now, in this chapter, or in this unit, I should say, a lot of times they leave it like that. So understand that this right here, if you get to this point, or you get to the point where you're writing it, x plus 1/4 x, that's not necessarily wrong. However, if we were going to finish simplifying it, which means get it to its simplest form, that means we would actually add these together. And it might be helpful for some of you to look at the 1 plus 1/4 here, because that's exactly as the same thing here and here. So you should know that 1x plus 1/4 x would give us, well, remember that 1 becomes 4/4. Well, I don't know what's up with that, but anyway, 4/4 x plus 1/4 x. So this is like saying x is pieces of pizza. Well, if I've got 4/4 of a pizza, that's an entire pizza, plus 1/4 of a pizza more, gives us 1 1/4 pizzas. But to leave it in its fraction form, that would be 5/4 x, which, as you can see, is the exact same thing that we got here. Same thing, just approached in two different ways. Both of them are correct. I am going to show you one more thing that we're not going to see right away, but I just want you to understand the difference between, just in case we do run into it in the near future, and we already kind of have seen it before, and we're not confused by it. So sometimes you might see something like this. you might see 4 times the quantity of x squared plus 3x. Wow, that's so silly looking, huh? Now, it's really important that we understand that x squared is never the same as an x. Remember, x squared is equal to x times x, and clearly that's not the same as just a plain old x. Not the same. So it is important that you remember that, because sometimes people see x's, oh, x and x and x, we can put them all together. You can't if one of them has an exponent. So here we go. You ready? Woo! Woo! So that means I've got 4 times x squared plus 4 times 3x. 4 times x squared, so that's like saying that I've got 4x squared. Whoops. So 4 of them, of course, that tells me I have 4x squared. So that's what this one is here, 4x squared. And now 4 times 3x. Remember, 3x means I'm multiplying x times 3, so I've got 3 x's for each of those, so that would be x plus x plus x. And I've got 3 of those, so here's 1, 2, 3, 3 x's. So 3 times x, I actually got a little bit ahead of myself. I get all excited when I do these, don't you? Well, if not, you should be, because you're doing it wrong. If you're not excited about it, because it's math. But anyway, I got ahead of myself. So 3x's is this first one right here. X plus x plus x. That's what 3x looks like. But this number right here tells me that I have 4 of them. So here I've got 1, 2, 3, 4. So how many x's do I have that I'm adding together? Hopefully, you know, 3 times 4 is 12. So I know that that's going to be plus 12x. I apologize if I confused you. Rewind and come back, or come ask me. But again, 3 times x is just this first one right here. That's how it's broken down. And then I have that 4 times, because it says to multiply those 3 x's times 4, which is what gives me this. And this right here is our final answer. Now again, we're not going to be seeing any of these right away, but we will be seeing them in the pretty near future. So I wanted to make sure that you've at least seen it before. We will go over this again. So I think that's all that you need to know about the distributive property right now. We'll be doing lots of examples in class to help you get familiar with it, but these are the basics, and hopefully you put all of this in your notebook.